Hi, everybody. So as promised, we're circling back to cover the power reducing formulas in section 5.3. The power reducing formulas are derived from the double angle formulas for cosine 2 theta, which I put here just for reference. So the first power reducing formula is this one here. Sine squared theta equals 1 minus cosine 2 theta all over 2. And where that formula comes from is if you take this third version of the double angle formula for cosine and you solve it for sine squared theta, you get what you see up here. And then there's also a power reducing formula for cosine. Cosine squared theta equals 1 plus cosine 2 theta over 2. Notice those two look very similar, except for the sign SIGN in the middle. And this formula comes from the second version of the double angle formula for cosine, if you solve this one for cosine squared theta. And then finally, there is a power reducing formula for tangent. Tangent squared theta equals 1 minus cosine 2 theta over 1 plus cosine 2 theta. And that just comes from writing tangent squared theta as sine squared theta divided by cosine squared theta, and then replacing each of those with their power reducing formula. So if you divide this expression here by this expression here, you just get this. All right, and we do use these formulas a lot in Calculus 2 and maybe even at the end of Calculus 1. So here's an example of how it's used. In this problem, we're going to write an equivalent expression for sine of x to the fourth, sine to the fourth of x, that does not contain powers of trigonometric functions greater than 1. And this is one of those problems where the directions maybe don't do the best job of capturing what they're looking for. So you really need to see an example of this type of problem before you do one, I think. So here's how we're going to do this. I'll walk you through it step by step. First, we're going to write sine to the fourth x as the square of sine squared x. And then we're going to replace sine squared x with its equivalent expression from the power reducing formula. Remember, the power reducing formula said sine squared x equals 1 minus cosine 2x over 2. All right, so we're going to square this expression. So let me explain what's going on here. I'll do the easy part first. Obviously, 2 squared equals 4. That's where that comes from. And this expression on top comes from squaring the binomial 1 minus cosine 2x. So if you can picture 1 minus cosine 2x times 1 minus cosine 2x, and you FOIL that, you get 1 times 1 is 1. 1 times minus cosine 2x is minus cosine 2x, and then minus cosine 2x times 1 is another minus cosine 2x. That's where that's how you get 2 of them. And then finally, minus cosine 2x times minus cosine 2x is just the square of cosine 2x. All right. So we're making progress. Remember, the directions were write an equivalent expression for sine to the fourth x that does not contain powers of trigonometric functions greater than 1. So what we've done so far is knocked a fourth power down to a second power. So that's progress. But we're not done yet because we still do have one power that's greater than 1. All right, so the next thing we're going to do is break up this fraction. See, you have 3 terms in the numerator. So we're going to divide each of those terms by 4. Like I said, just breaking up the fraction. And now we're going to take this cosine squared 2x and we're going to apply a power reducing formula again. And this is what you get. And this is the part where sometimes I'll lose a few people. So let me explain what happened here. So the, let's see, the power reducing formula talks about cosine squared theta, right? So in this problem, or in this part of the problem, I'm sorry, 2x is playing the role of theta. So just imagine that that circled thing was a theta. We're replacing the theta with 2x. So when you apply your power reducing formula to cosine squared 2x, you get 1 plus the cosine of 2 times 2x all over 2. Remember, the formula was cosine squared theta equals 1 plus cosine 2 theta over 2. Okay. All right, so now I'm going to go to the next slide, and I believe the next slide will have this step here rewritten at the top. I think that's what I saw when I looked at this. Yes, there it is. So we are just about done. All we have to do now is just clean this thing up. All right, so nothing needed to be done with these two terms. And then in this term here, I'm just multiplying 1/4 by this expression, gives me an 8 on the bottom, and I'm writing the 1/8 in front. Now I'm going to distribute that 1/8, and that gives me, well, let's look at the whole thing. 1 minus 1/2 cosine 2x plus 1/8 plus 1/8 cosine 4x. And the only other thing I can do is combine the two like terms. We have a 1/4 and a 1/8. So I'll add those together, and I get 3/8 minus 1/2 cosine 2x plus 1/8 cosine 4x. So one last time, the original instructions were write an equivalent expression for sine to the 4th x that does not contain powers of trigonometric functions greater than 1. And we've done that. There are no powers of trigonometric functions greater than 1. The trade-off is that instead of having a sine x or a cosine x, you have a cosine 2x and a cosine 4x. This is similar to something that you're going to see in the next section. In the next section, we're going to talk about the product to sum formulas. And what this and the product to sum formulas have in common is that they are used to rewrite an expression in mostly calculus 2 that will make a certain kind of problem called integration easier to do. All right. So someday in calculus 2, you may be asked to integrate sine to the 4th x. And in order to do that, you will have to rewrite sine to the 4th x like this. All right, and that's going to do it for now with the power reducing formulas. We'll see you next time.